What up, my dudes? This is Mr. Gardner, and this is Math Time with Mr. G. Today we're going to be doing solving system of equations, and just a reminder, a system of equation just means that I'm going to give you a bracket with a list of equations. So it might be like y equals 2x minus 1. It might say f of x is equal to 3, things like that. The only new thing is we're adding quadratic equations to the mix with f of x is equal to x squared plus 3x minus 1. That's it. We're adding this here. And what we're trying to figure out is if I give you a parabola and a line, where do they cross? That's it. Or where are those 2 points? And there's 3 strategies we're going to use to try to figure this out. First one is going to be elimination. So what I'm going to do is I am going to multiply everything in here by -1. And the reason for me doing that is then it'll become y equals x squared minus 6x plus 8, and negative y is equal to negative 2x plus 4. And the reason we did that is now we can add all of the like terms together. So y minus y is 0. And then x squared, there's no x squared below, so I'm just going to write x squared again. Then I have negative 6x minus 2x, and that's going to give me negative 8x. And then 8 plus 4 is 12. And why that's useful is now I have it's equal to 0, and I could factor and say x plus 2, x minus 6 and x minus 2. And that gives us 2 times 6 to get us to 12, but 6 plus 2 to get us to 8. And there are our 2 equations. So x minus 6 is equal to 0. So x is equal to 6. And same thing. X minus 2 is equal to 0. Add 2 to both sides. X is equal to 2. Which means that the 2 points that these cross is at 6 and 2. Which means if I were to put these on a graph, it means I would have some kind of parabola, some kind of cross, and they would cross at 2 and 6. And I could plug those back in to find the y values as well. Another technique we could do is substitution. So I could multiply this by -1 like we did before, and then do elimination and add the columns. Or I could just say, hey, these are both y equals, which means that these are equal to each other. So that means I have 20x is equal to negative 2x squared plus 20x, or 60x, I'm sorry. And the same thing, we just have to get equal to 0. So I'm going to subtract 20x from both sides. I have 0 is equal to negative 2x squared plus 40x. So I can factor, I can pull out the greatest common factor, and I'm actually going to try to pull out the greatest common factor for this one. So that means I have negative 2 and x, which leaves x is still inside, because if I were to distribute, I get back to here, and I get negative 20, because negative 2 times negative 20 is positive 40, and the x. Now that I have my 2 factors, I can set both of those equal to 0, and solve for x. So my 2 x-intercepts are at 0 and 20. And again, I have some kind of parabola, some kind of line. They cross at 0, and they cross at 20. And the last strategy we can use is we can just graph. So the way I'm going to do this is I'm going to just start at +1, and then 0.5 is the same as 1/2, so that means to go up 1 over 2. So there's my graph there. And then this one, this is my y-intercept at +3. And I'm going to find my axis of symmetry. So it's going to be negative b over 2a, which means it's at 2, -2, or -1. So I know that's my x part of my vertex. To find my y, I plug it back in. And I get 4. So my vertex is at -1, 4. And so I would say I have 1 at, for where they cross, because that's what they're asking for with the solution of where they cross, is at -1, -4. And then I have another one at like 1/2 and 1/2. So the other two give us perfect answers, whereas us graphing it gives us a rough answer of kind of 1/2, kind of 4, but it's a quick, easy way for us to see where our ballpark is. Well, if you guys have any other questions on the 3 strategies, just let me know in the comment section. But other than that, be kind to each other, ask lots of questions, and think deeply.